All right, hey everyone. So we are going to introduce hypothesis testing with this video. And so hypothesis tests will be kind of a major focus for us throughout the rest of the semester. So get excited and also kind of realize that um, this is kind of the first hypothesis test we're seeing out of many, many. And so if it doesn't quite all click the first time, that's totally fine. Just for hypothesis tests with categorical or with a single categorical variable, we'll actually see three different examples. And so this will just be the first of those three. We'll see the other two at least we'll get started with in class so that you can be working on them and ask your partner or myself any questions as you're working through. So the example that we're using is from this video that you could either watch or not. It shouldn't make too much of a difference, but if you remember from the beginning of class, the very first quiz, there were three questions that appeared just kind of randomly. There was one about the whether the percent of people who live in poverty has like increased or decreased over the last 50 years or so. There was a question that I'm blanking on now, but there was a third question that we're going to use for this example that just asked, on average, how many years do women spend in school? And this was a global question. And so the question had also said that men on average spend 7 years in school. And so it was your kind of job to answer as best that you could whether this was 7 years, option A, 5 years, option B, or 3 years, option C. The results of this were that 15 students answered option A, 32 students answered option B, and 9 students answered option C. And so you could kind of, the wording of this is a little bit off because it's worded as if we're actually attending class, but we could still write down how many people took this quiz, so answered this question, and that would be 47 plus 9 is 56. And so our sample size denoted by n is 56. And the correct answer for this is actually A. And so today, worldwide, women spend on average about the same amount of years in education or in school as men do. So we see that 15 out of 56 people answered this question correct in our class. So a natural question to ask is whether SLU students, and particularly you guys, answered the question better than what would happen just under randomly picking one of those options, which we're going to call random guessing, or if you actually answer the question worse than what would happen under random guessing, or if you kind of answer equivalently to just randomly selecting A, B, or C. And so our variable of interest here is going to be whether or not the question is answered correctly. This is going to be categorical with just 2 levels, correct or not. So there's a little bit of a trick here in that it's categorical. It doesn't have 3 levels because we're not really interested in the distribution of the 3 choices. We're only interested in whether or not a student answered this correctly, which just has 2 levels. It's either correct or not. And so the idea is that if we were all just randomly guessing at this question, we would expect about 1/3 of us to get the question correct. So if everyone was just randomly choosing A, B, or C from those options, about 1/3 of the people would say A and get it correct, 1/3 would say B, and 1/3 would say C. So take a second to go ahead and think about these three questions. So if we were more knowledgeable than random guessing, what would you expect the proportion to be? If we were less knowledgeable than random guessing, what would you expect the proportion to be? And even if we were randomly guessing, would you expect exactly 1/3 of us to get the question correct? So go ahead and pause the video and take a second to just think about those three things. Okay, so for these first two, if we were more knowledgeable, then we would expect a lot greater or a lot more than 1/3 of us to get that question correct. So think of the extreme case where if it was a super obvious question like, uh, uh, I guess like what color is the sky on a clear day, yellow, green, or blue? Then all of us should get that right. We should all say blue, and so the proportion getting it correct would be 1, which is a lot higher than 1/3. If we were less knowledgeable than random guessing, then the proportion of us getting that question right would be much less than 1/3. That indicates that we're doing worse than just randomly picking one of those options. And then the really key idea is that even if we were randomly guessing, our proportion that get the question right isn't going to be exactly 1/3. And so not necessarily. In this case, our sample size was 56, so it's actually impossible for our sample proportion to be exactly 1/3 because 56 isn't divisible by 3. But either way, even if it was, this would be not necessarily. There is sampling uncertainty or sampling variability. So we talked about this a lot already, that this idea that if we took random samples over and over again, we're going to get a different sample proportion each time. And so it's not necessarily going to be 1/3, even if we were just randomly guessing. Okay, and so this last question just has to do with representativeness again. So is our sample of Stat 113 students representative of all SLU students for this example? We will say yes, but there could be arguments against this assumption. So you could think about arguments that Stat 113 students tend to be younger compared to SLU students as a whole, and could have different majors. And so we tend to get less humanities majors in Stat 113 just because it's not required like it is for econ or for psych or for stat, obviously, or business or other majors like that. All right, so we will kind of pick up next time really delving into writing out hypotheses. This first video is just kind of a setup to get us thinking about what sampling variability is going to be, and it's going to steer us into kind of making our null and alternative hypotheses in the next video.